we're going to do pages 12 through 4. And question 40 starts at the top of page 12. It says, write the inverse function of the following functions, clearly showing all of your steps. So I'm going to do A with you guys, and then when you break up into your groups of 4, you're going to do B. So for part A, we started with the function 2 times the quantity x minus 1, all to the third power. So it really helps if you write the steps down in the correct order of what they would happen for order of operations. Please excuse my dear Aunt Sally, or PEMDAS, however you want to refer to it, okay? So think about it as, what's happening to this x? Okay, to this x, first thing that's happening is 1 is being subtracted. Second thing that happens is it should be cubed, okay? Third thing that's happening is all of that is being multiplied by 2, okay? So for the inverse, we want to do 2 switcheroos, right? 1, go in the reverse order, and 2, do the inverse operation, okay? So the inverse operation of multiplying by 2 would be dividing by 2. The inverse operation of cubing would be cube root. And the inverse operation of subtracting 1 would be adding 1. So when we write our inverse operation, first thing we want to do is divide by 2. So I just write it as a fraction. But if you like that division sign, use it. Second thing we're going to do is take the cube root. Make sure you know how to find the cube root in Desmos. If you haven't done that yet, it's in the little keyboard thing that you pull up. But make sure you can find it. And then the last step is you would add 1 after, okay? When you break up into your groups of 4, write your steps down in order, then reverse them, inverse them, and then write your function, okay? Question number 41 is about Adriana's strategy for checking that the function f of x and f inverse of x are inverses of each other, is to think of them as stacked function machines. She starts by choosing a number to drop into f of x. Then she drops the output from the f of x into the f inverse of x. If she gets her original number, she is pretty sure that the 2 functions are inverses. Okay? Part A says choose one of the problems from 540, then use Adriana's idea to test them. So I used A, and you all know how much I love 0, so I wanted to make the parentheses 0, so I chose 1. So when you plug in 1, you follow order of operations. 1 minus 1 is 0, 0 cubed is 0, and 2 times 0 is 0. Okay? So we're going to take that output of 0 and plug it into our inverse operation. So under that cube root, we have 0 divided by 2, which is just 0. And then the cube root of 0, which is also 0. And then 0 plus 1 is 1. So we end up with the input that we started with for our regular function. So we say, yep, it worked out. They are definitely inverses of each other, and we got what we wanted, okay? Part B says Adriana wants to show her work algebraically. She knows that if she chooses her input for f of x to be 3, she can write the output as the function of 3. Next, f of 3 becomes the input for f inverse of x, and her output is 3. Is the new input for f inverse of x. She thinks that she can write this process of f inverse of f of 3. Does her idea make sense? Why or why not? Okay. She actually plugs the original function into the inverse function. So she's plugging it inside of the inverse, the original function, and she gets out 3. Does that make sense? Yes, you can technically do that. The output of f of 3 becomes the input for the f inverse function, and the output of that inverse function is 3. So it's like inside, you want to work from the inside out. You would do the f of 3, get the number, plug it into the f inverse of 3, and 3 was originally what she plugged in, so that's what you get out. Any questions on problem 41? All right, anybody still writing? Okay. Let me know when you're ready, August. Okay, turn over to the top of page 13. Question, or part C from the previous question says, does Adriana's strategy confirm the functions are inverses of each other? Is there anything else she should check? Yes, it confirms it. You just want to check both orders. Part D, use your strategy from part C to confirm that f of x is the inverse of the f inverse of x. Write an equation that your results algebraically using the notation from part B. So it's going to, the inverse of 3, plug it into the function, and you actually get out 3. It's kind of like redundancy. Part E, will this strategy for testing inverses work with any input? At this point, we have only dealt with real numbers so far, and they have all worked out. Is that good right there? Okay. Adriana had to find the inverse function for the f of x of minus 3 squared plus 2. She got the equation f inverse of x equals the square root of x minus 2 plus 3. Will her stacked function machine method work? Use Adriana's idea from problem 541 to verify that the functions are inverses of each other. Each person on your team should choose a different number for the input. Be sure to stack the function machines in both orders. Okay? So when we're done, you're going to break up into your groups of 4. You're all going to randomly pick a different number, plug it in, get an answer, then plug it into the inverse. Okay? Then you should spit out whatever you plugged in. Okay? That part should work out just fine. Then we get to part B. Part B says, Adriana's friend Symmetra, is that how you would say that? Symmetra? Symmetra decided to check f inverse of the function of negative 5. What happened and why did this happen? Okay, so we're going to plug in negative 5. When we plug in negative 5, we're going to follow our order of operations. Negative 5 minus 3 more is negative 8. Negative 8 squared is 64. And then 64 plus 2 is 66. When we get 66 as our answer, we're going to plug that into our inverse. So we plug in 66. 66 minus 2 is 64. And the square root of 64 is 8, but it's also negative 8. So we're going to have positive 8 plus 3, and we're going to have negative 8 plus 3. So when we have 8 plus 3, we get 11. Is that what we wanted? No problem, okay? If we plug in negative 8 plus 3, we get negative 5. That's good, right? Negative 5 is what we expected and what we wanted, but this 11 right here is not what we wanted, okay? This means we cannot confirm our inverses, and we need to do something called restrict the domain, okay? We're going to restrict the domain. Anybody still writing? No? We're all good? Awesome. Okay, so we're going to go over to page 14, and we're actually going to look at the graphs of these guys. And I did it in 2 different colors because that makes it a little easier for you to tell. So when you go into Desmos, you can type in these 2 equations, the function of x, which they gave us, which was the x minus 3 quantity squared plus 2, and then the inverse function of x, which you should have gotten, the square root of x minus 2, and then add the 3. When you type them into Desmos, the top one in pink is your parabola. It's shifted some, right? It's shifted 3 this way, up 2. But then the inverse function of x is just going to give you this little part right here, going off to the right, okay? If you could imagine this little dashed part of it going down this way, you would have essentially a parabola going to the right. Like it almost just turns it 90 degrees to your right. But when you graph it in Desmos, it doesn't give you that part of it because that is not part of the graph, okay? So we have to do what's called restricting the domain, okay? To restrict the domain, we say that x must be greater than or equal to 3 on that square root function, okay? Because it will not pass the vertical line test at x is greater than or equal to 3, okay? You can confirm that in Delta Math if you need to. I'm just not pulling it up right at the moment. Okay. Anybody still drawing down those graphs? No? Oh, sorry. You good? Okay. For question 43, it says Adriana and Statler are writing inverses of some functions. They come up with these inverse pairs. And they don't tell us to do anything with them. I'm a little, there's like no work to be done there. It was a little strange. So question A, or part A, says, name 3 different methods Adriana and Statler can use to verify that these pairs of functions are actually inverses, okay? So we've learned 3 methods so far. The first method we've learned is to undo the functions step by step and go in reverse order, okay? A second method we've seen is to create a table for the function, and then for the inverse function, just swap those numbers, right? And then on Friday, you should have seen where the graphs will reflect over a line, and it's that crooked line, that y equals x, okay? Those are the 3 ways we've learned so far, all right?